Now we are going to talk about parallel propagating waves. These are again the electromagnetic waves in plasma. But for parallel propagation, we means K is parallel to B naught. So we are going to consider this geometry that K is along B naught. And to satisfy the electromagnetic waves condition, we have E1 perpendicular to K. So as these are the electromagnetic waves, we again have these equations, the Maxwell's equation that we are going to use. As we have solved in the previous lectures, these equations, and we get this expression, this omega square minus E square K square E1 and this K dot E1 and E1. Now by solving the equation of motion for the electrons, we have this Vex and Vey as previously we have derived it. So now we are going to use these values in this equation. As you can see that if I go with this geometry, this K dot E is going to be 0, and we have left with omega square minus C square K square Ex with Vex and Ey with Vy. So now just I'm going to write the components of this equation. Omega square minus C square K square Ex equals iota omega n naught E by epsilon naught Vex. Similarly, I can write omega square minus C square K square Ey equals iota omega n naught E by epsilon naught Vey. So now I'm going to substitute these values in this equation and then try to find an expression in terms of Ex and Ey. So by substituting these values, as you can see, we have, let's say, so if I substitute this value there, omega square minus C square K square Ex. So this n naught E by epsilon naught and this term. So you can see iota omega n naught E by epsilon naught into minus iota E over m omega, and in bracket what we have, and then 1 minus omega C square by omega square. So from here you can see that minus iota and iota will give you a plus, and n naught E squared by epsilon naught m will give you the plasma frequency, and omega will cancel out, and I am taking this term to this side. So we have omega square minus C square K square to 1 minus omega C square by omega square Ex equals omega P square, and what we have in bracket here is Ex minus iota omega C by omega Ey. Now by just rearranging these terms, we are going to get omega square minus C square K square minus omega P square by 1 minus omega C square by omega square Ex. This term will come here, and plus iota omega C by omega P square by 1 minus omega C square by omega square E equal 0. In a similar way, we will get an expression in terms of E phi and Ex again by solving this term, this form for Vy also. So we have this omega square minus C square K square minus omega P square by 1 minus omega C square by omega square Ey minus iota minus c by omega. Now again we get equations in terms of Ex and Ey, and these are coupled equation, and we can solve it by using the matrix identity. So I can write it in this form. As we have already done it for the X mode case, we have this A and B and this C and D. We have A and B, this is C and this is D, because Ex will come up here and Ey is going to be here. So we have AD minus BC is for the matrix. So we have omega square minus c square k square minus omega p square minus omega c square by omega square whole square equals alpha square of omega p square by whole square omega c square by omega square. So now we are going to solve this expression. As you can see, these are all in the square terms. So if we take the square root, the square will be cancelled out and we have a plus minus over here. So we are going to have omega square minus c square k square minus equals plus minus omega p square by omega c by omega. Now if we rearrange these terms, we will end up actually we want to find out the relation of c square k square by omega square.